Hey everybody, Mrs. Lowe here. You should be following along with your chapter 3.1 note guide as I complete this. There's a couple that you need to do on your own. This is solving linear equations by graphing. You're to do the team challenge and the Are You Ready next class with your team. So this, you should come in with these not finished. So this will be next class with your team. So the two objectives today are to be solving system of linear equations using graphing and to determine whether it's consistent or inconsistent. So the missing words that go in here are to, linear, intersection, and satisfy. So a system of linear equations is a set of two or more linear equations where the solution is the point x comma y. It's the point of intersection. Hence, this coordinate satisfies, that should be plural, both equations. So basically, you're graphing two lines and you're looking to determine where they cross, and that is the solution to the system of linear equations. There are other methods. In fact, there are four methods used for solving. We will be tackling three of those: graphing, elimination, substitution, and matrices. We may or may not get to matrices. So those are the four methods used to solve a system of linear equations. We are going to first determine whether a point is a solution. So it says determine if the given ordered pair is a solution to the system. So you're given a point x comma y and you're going to determine whether it's a solution. So first you're going to substitute the point in for the x and y of each equation and you're going to see if it's true. So I substituted the x in for 4 and the 3 is y, and I determined if the left side equals the right side, and it does. So that just means that's a point on that line. In order for it to be a solution, it has to be a point on both of the lines. So I have to substitute in for the blue one as well. So 3 times 4 minus 3, is that equal to 9? And that's 12 minus 3. It is. So therefore, 4, 3 is a solution. Now, that doesn't tell us if it's the only solution. It just tells us it's a possible solution. So you're going to try B. You should come in next class with this done. This must be done. That's part of the expectation as you finish B. Moving on to number 2. Number 2, we're going to actually graph the system and we're going to determine the solution. So I have a graph here to the right. I'm going to first indicate which graph is which color. I'm going to graph 2y equals x minus 6, but first thing I'm going to do is divide everything by 2 so I can get it in y equals mx plus b form. So I divided the right side and the left side by 2. So the y-intercept is -3. I go up 1 over 2 for my slope, up 1 over 2, or I could go down 1 over 2, and then I would connect my points. I'm not using a straight edge, but you should because it's really important that your lines are straight. Now I'm going to graph this one. This one's also already in y equals mx plus b. Well, I see they have the same y-intercept, so I already know where the point of intersection is. -3 up 4, 1, 2, 3, 4 over 1, up 4 over 1, or I could go down 4 over 1. So when you connect this, you can see that they intersect at one point. And where they intersect is right there. And we would write the point of intersection as x comma y equals, and then the point of intersection. The point of intersection is 0, -3. Simple as that. I would not give you a graphing one that doesn't come up as an integer point because it's just too hard to estimate. So anytime I ask you to graph, you can assume it's going to be an integer point. So you're going to try D, graph both lines and write the solution. So you should come in with that done. Down at the bottom, you see this table. This table summarizes the 3 types of solutions. You can have 1, infinite, or none. If it's consistent, if the system is consistent, it has either one solution or infinite solutions. So consistent means a solution exists. If it's inconsistent, that means there's no solution. That means the lines are parallel. So consistent, solution exists. Inconsistent, it does not. So we're going to fill in these words. 1 is the first missing word. Infinite is the next. Same. No. Parallel. Consistent. Inconsistent. So this says a system of equations can have exactly one solution. It's known as independent. It could have infinite solutions. If they're the same line, that's known as dependent because they depend on each other. Both of those are considered consistent. Or it could have no solutions if they are parallel lines, and that would be inconsistent. So a consistent system is a set of equations that has at least one solution. That'll be 1 or infinite. And an inconsistent has no solutions. I need to fix that because that should be a 1. So this one, it says determine if the system is consistent or inconsistent and state the number of solutions. So you're just determining whether there is one infinite or none solutions. And I'm going to do that by solving these both for y. And I'm going to compare the lines. So if I move the 7x over, I would get negative y equals negative 7x minus 11. And then I divide by negative 1, I would get 7x plus 11. Now I'm going to do the other line, solve it for y. Oh, I wanted to use a different color so you guys could see that. So all I have to do is divide everything by 3. I get y equals 7x plus 11. So what do you notice about those two? They're the exact same line. That means they are on top of each other. That means a solution does exist. In fact, that would be consistent. And there are infinite solutions. Infinite, because every point on that line is a solution to that system because it's the same line. All right, F. I'm going to set this equal to y. Well, it's already done. I'm just rearranging it. For the next one, I'm going to divide everything by 5. So I get x plus 7. Well, you should notice that these have the exact same slope, 1 and 1, but they have different y-intercepts, 4 and 7. That means they are parallel lines, and parallel lines never touch. Therefore, there is no solution. So this is inconsistent. No solution. So all we did was solve them for y, compared the equation to determine if they're the same or parallel. All right, we have a little word problem here. This is biking related. It says Mrs. Lowe is competing in a bike race. She traveled 12 miles at an average speed of 15 miles per hour. So I've already gone 12 miles and I'm continuing at an average speed of 15 miles per hour. Sam is competing in the same race. He gets a flat tire. He had traveled 8 miles already, and then he is moving at an average speed of 18 miles per hour. Let x equals the number of hours and y equals the distance traveled. Write the system of equation and graph it on Desmos. Then determine how long will it take Sam to catch Mrs. Lowe and how many miles in the race will that be when they meet. Well, first you write a system of equations. Since there's 2 people here, we've got Sam and Miss Lowe. I've highlighted Mrs. Lowe's information. I've traveled 12 miles, so that's 12, plus I've gone 15 miles per hour. So y is my total distance and x is the number of hours I would travel. Sam has already gone 8 miles and he's traveling at 8 miles per hour, or excuse me, 18. So there's Sam's equation. Notice that's in y equals mx plus b. And when you go to Desmos, Desmos is awesome. You can graph the 2 lines. Notice the 2 colors match up. And then you're looking for the point of intersection. So I'm going to zoom in on the point of intersection, which is right here. If I scroll over, I get 1.33 and 32. So there's my solution. 1.33 is 1 1/3 hours. So that's 1 hour and 20 minutes. So it will take Sam another hour and 20 minutes to catch me. And looks like we've gone, looking at it again, 32 miles. So you write the system, you can graph it on Desmos, or you could graph it on paper. The problem is, you need a big sheet of graph paper for that. So that's solving systems of equations by graphing. You will work on the problem set next class. You're welcome to begin that, but it is due that night of the next class. Hope this was helpful.